Well, let's dig a little deeper into using the centroid theorem. Now, of course, the centroid theorem, it starts with the fact that triangles have medians. A median is a segment drawn from the endpoint of the vertex, a vertex, to the midpoint of a line opposite that vertex. And of course, in a triangle, there's going to be three medians. And where the point of intersection is of those medians, those three medians, that is called the centroid. And one of the interesting things about a centroid is that it also is the balancing point or the center of gravity for a triangle. And so if you determine where the centroid is, you could put a triangular shape, let's say on a stand, on a pedestal, even one with a very, very small diameter, and gravity is not going to cause that triangle to fall. It's going to be in balance. Now, if some other force acts upon it, then of course it may fall, but not by just gravity alone. That's one of the advantages of knowing what a centroid is. Now, another thing about a centroid is that the length of the centroid from the vertex to the centroid I should say median. The length of the median from the vertex to the centroid is 2/3 of the total length of the median, and from the centroid to the midpoint of the line opposite is 1/3 the length of the median. So let's see, we're going to be doing PS. I'm going to use this one up here, the KT. So KT, 2/3 of the length of KT is from KP. That's from the vertex to the centroid, and 1/3 is from PT, which is from the centroid to the midpoint of that line JL, or to point T. So that means that there's actually 2/3, 1/3. There is a 2-to-1 relationship. 2/3, 1/3. There's a 2-to-1 relationship between the segments that intersect at the centroid of a median. So let's see how we can apply this. It says in triangle JKL. So here we got JKL. We see the triangle. That RP is 3.5. Let me put this in a different color. So RP is 3.5 and JP is 9. All right, find each measure. So now RP represents the portion of the segment from the centroid to point R, which is the midpoint of line JK, and segment JP is the portion of the segment JS between, and that is between J, the endpoint J, and the centroid. All right, let's having to find that. Now find each measure, PL. Well, PL is going to be 2/3 of the total length of RL, and so that means that it's going to be twice as far, or have twice the length of RP. There's a 2-to-1 relationship between these two segments. One of them's 2/3, one of them's 1/3. If you cancel out the denominators, you got a 2-to-1 relationship. So PL would be twice the amount of RP, which means that PL is going to equal 7. Now, let's see, PS. All right, so we're trying to find this. Well, this is 1/3 of the length of that segment, which means that it'll be 1/2 the length of JP. Again, we got a 2-to-1 relationship, and now we're looking at the shorter segment, so it's going to be 1/2 the amount of the longer segment. And so I can take 9 and divide it by 1/2, and so that should be that PS is going to equal 4.5. All right, so within a median, when we're looking at it in terms of from the centroid, there is a 2-to-1 relationship, 2/3, 1/3, between the length of those segments. And you can easily find those if you're looking at the longer segment. If you know the measurement of the longer segment, you could take half that amount, and that's going to give you the length of the shorter. Or if you know the length of the shorter measure, multiply it by 2, and that'll give you the length of the longer segment using the centroid theorem. Centroid, that sounds like something out of Star Wars. R2-D2.